Okay, so today we are starting on squares. So if you look at page 7 in your packet, we're going to start filling out our web. First, we've got to do all of the congruent markings. Now, if you followed through this web, we started with parallelograms, and what we had in parallelograms were also in rhombi, except we built on it a little bit by adding some other stuff. With that, we're going to use what we had in rhombi and put it with our square. And we're also going to use a little bit from our rectangles and put that with our square. So to start, all of the sides in a square, kind of like the rhombi, are congruent. It means all 4 of those sides are the same. Now, unlike the rhombi, but like the rectangle, all of the diagonals on the inside of your square are identical. That means they are all the same length, no matter which one of the 4 it is. Like the rhombi, we have right angles in our center. And like the rectangle, we've got right angles in our corners. Now the only difference here is in the right angles in the corners of rectangles, those could be any number, didn't have to be perfectly cut in half. However, in your square, they are perfectly cut in half. So both of those angles are going to be 45 degrees. Like in all 4 of these, well, I guess all 3 since this is the 4th, opposite sides are still parallel. And then the very last thing, which has been true of all of these, the 2 corners on the same side, or the consecutive angles, are going to add to equal 180. They're also known as supplementary. Now, if you flip to the next page, make sure my page is straight. There we go. If you flip to the next page, you'll notice that this has the most amount of stuff. That is because we're building everything. So the first 5 you had up here in parallelograms are going to be your first 5 here. Then you're going to take a little bit from the rectangles and the rhombi. And here's what I mean by that. So my parallelograms up here, opposite sides were parallel, opposite sides were congruent, opposite angles are congruent, consecutive angles are supplementary, or 180. You can put either right there. Your diagonals bisect each other. So that was the same 5 as the parallelograms. Now I'm going to take the 2 last ones from rectangles, because those are also true, and add them here. My corner angles are 90 degrees, and my diagonals are congruent. Then I'm going to take, sorry, I have to find the right color pen. Hope it's this one. Oh, nope. Maybe it's this one. We'll see. The same as the opposite of the rhombi. So that means all the sides are congruent. Ooh, yeah, I picked the right pin. That also means diagonals bisect the angles. That also means diagonals are perpendicular, which means there's a right angle formed. So all I've done so far with my squares is just kind of combine everything on this paper. Now you're going to turn all the way back to the squares. And that would be on page 14. Now we want to make sure, let's make sure I'm zoomed in enough. Okie dokie. So on page 14, we're going to start just by figuring out all of the different sides and angles. This is what we do at the beginning of each one of these quadrilateral sections. No different for squares. It says if ABCD is a square. It's important to note that because otherwise you could possibly argue that it was a different quadrilateral. If it's stated it's a square, it has to be a square. It says AD is 11. That's that side there. Find each missing value. Well, I'm going to go through and figure out what I know. I know if this is 11, all of these are also 11. It's a square. All four sides have to be the same. I also know that in these corner angles, they are going to equal 90. I also know that these inside angles, where my diagonals intersect, are perpendicular, which means they are 90-degree angles. So now I can go through it and figure out what I can fill in and what else I still need to find out. So far, BC, we've done that one. It's the side of a square, it's 11. Then I need AC, that is a diagonal. I don't know any sides inside my triangle right now, so I'm going to skip it. BD is inside, so I'm going to skip it, and EC is inside, so I'm also going to skip it. Now, looking at the angles, I know all of the angles in this triangle already, so we're going to go and fill those in. DAB is this whole corner angle, so that means it is 90 degrees. AEB is this angle right here where my finger is. I know diagonals bisect, or diagonals are perpendicular to each other, sorry. So that means that angle, 90 degrees. CBD, that's half of this angle. I know half of a corner angle, no matter which corner, is going to be 45 degrees. BAC, that's another half corner angle, so that's another 45 degrees. Now I've just got to figure out how to find those diagonals, so then I can divide it in half to find the half diagonal. Now if I were to redraw this triangle, it's a right triangle. Probably the best triangle I've drawn this whole time. And of course my diagonal is going to be this diagonal piece right here. That diagonal piece right there is my hypotenuse. If you're doing the Pythagorean theorem, you would use the letter C there. Now because I'm finding my hypotenuse, you are taking the square root of leg squared plus leg squared. In this case, they're both the same thing. When you type that in your calculator, you would get 15.6. So if 15.6 is my whole diagonal, let's figure out the rest of these pieces. BD, that's another whole diagonal, so that's going to be 15.6. EC, that's a half diagonal. So to figure out a half diagonal, I divide it by 2. That means I'm saying 15.6 divided by 2. That would give me 7.8. Remember, just round to one decimal place. If you really feel like you should, you could round to the nearest whole number. I'm going to keep these to decimal places, though. Okay, we're going to flip over. There's not a whole bunch of notes on squares because squares are like the easiest of the quadrilaterals, especially with all the practice you've gotten this far. So we're going to start on number 2. Oh, you probably can't even see my page because I'm zoomed in. Let's fix that. There we go. Now you can see it. Now let's start on number 2. It says if STUV is a square, SW, that's this piece, we're just going to color code it, is 2x plus 13, and WU, that's this piece, is 8x minus 41. Now I've got two half diagonals. That means they have to be the same because they are congruent. When they bisect each other, that makes them be the same. So I'm just going to set this up with the bigger x on the left side and solve for x. Now when I solve for x, I'm going to subtract the 2x to undo it from one side and add the 41 to move it to the other side. That leaves me with 8x minus 2x, which is 6x, and equal to 13 plus 41, that is 54. When I divide both of those, x would give me 6. But this question is not just asking for x, it wants VT. Now, a second ago we said that we had two halves. That means in order to find the whole thing, you're going to plug x back into both, but instead of setting them equal, you are going to add them together. And I'm going to do this in this little space below so I have enough space. So I'm going to say 8 times 6 minus 41 plus 2 times 6 plus 13. Whatever that gives me has to be VT because that is the whole diagonal. Now if I were to put this into the calculator, 8 times 6 is 48. Minus 41 would give me 7. So this part is 7 plus 3 times 6 is 18, plus 13 is 31. So to figure out my whole diagonal, or VT, I would just add those, and I would get 38. Kind of ran into the practice space, but that's okay. Okay, then I've got this last one. And remember, all of the angles in a square we know, they're either 90 degrees if it's a full angle, or 45 degrees if you're looking at a half. This angle is looking at half of an angle, so I know it is 7x plus 3 equals to 45. Half an angle is always equal to 45. Full angle is always equal to 90. So if I were to move this to get x by itself, move this 3, let me specify. To get x by itself, I would subtract it because I'm doing the opposite. That would leave me 7x equals 42. Divide by 7 to get x by itself, and x is 6. That one was way faster because I didn't have to plug it back in to find anything out. If you've got any questions, please let your teacher know.